Good day and welcome to the Math Salon. I'm Dr. Anumendem. Today we'll be looking at equation on paper 3 advanced level, also on probability, but this time another tool, that is tree diagram. How to use a tree diagram to solve problems, usually problems that have compound events. So we will have an event that follows another one. Sometimes they could depend on the other or not. In this case, we will have some ideas of conditional probability come into play. These questions are usually lengthy, so we will not do much. So I suggest you pay much attention because more videos may not become in this direction because it takes so much time to read only the question itself. I will try to explain as much as possible so that you're also confident when you get into your exam. At least that's what I wish you do. I guess you too want the same. So let's see. So the question says 3 companies A, B, and C supply light bulbs to a construction firm. A supplies 30%, B supplies 45%, and C the rest of the bulb. So it's just 100% minus the sum of these two. It is known that 3% of those produced by A, 6% of those by B, and 4% produced by C are defective. These are not perfect. They are companies, they are machines producing. So if that is known, then a light bulb is selected at random. Let's assume that the bulbs are all mixed in one big carton and people have to pick any and use. They are all equally likely. Then we talk about random. So draw a tree diagram showing all possible outcomes. B. Find the probability that the bulb is defective. Given that the bulb is defective, find the probability that it was produced by company C. So that's how we are going to go about it. First, the tree diagram. From the notion of tree diagram, it looks like a tree. So it starts with a trunk that breaks up into branches, and the branches can break up into sub-branches, and at the end we have a canopy. So that's a bit the way it would look like, and I guess that's how the name comes about. So let's see. So for a tree diagram here, if we select a bulb at random, what will happen? So let's put a dot here. This is my bulb process. If I do select, then either it is from A or from company B or company C. Yes? And if it is from A, then it is either defective or not defective. It's important that when you're drawing a tree diagram that you indicate the labels that you use. So if you use A, B, and C, say that let the companies be A, B, and C. In this particular question, A, B, and C is not strange. The examiners know. But something like D and not D, you really have to define. So let defective be D, not defective and D. Or you just write them in words. It's also fine. Or it may come from B and it is defective or not defective. Or from C, defective or not defective. So it means my outcomes are either it is from A and defective, or from A and not defective, or from B and defective, or from B and not defective, or from C and defective, or from C and not defective. These are the possible outcomes that you have there. 1, 2, 3, 4, 5, 6. So in terms of A, this is your tree diagram indicating to you the possible outcomes that's there. So let's see B. Find the probability that the bulb is defective. I will now populate this tree diagram with probabilities on them. There are 3 companies. They don't all supply the same quantity of bulbs. So that must be taken into account, which means there are many bulbs in the box coming from one company than the other. A, for example, we are told that's 30% of them. So this is 30 on 100. B is 45. 45 on 100. These are the probabilities. And C is the rest. So that is 30 plus 45, that's 75, minus 100, that's 25. 25 on 100. If it is a bulb that was produced by company A, then the probability that is defective is 3%. That's 3 on 100. Means the rest are good. They're okay. And that should be 97 on 100. From D, defective coming from B, 6% of those produced by B. So this is 6 here on 100. And then the rest, 94 on 100, are good. and from C, 4%. So 4% are defective and 96 are not defective. Okay. Find the probability that the bulb is defective. If the bulb is defective, then it might have come from A, like here, or from B, like here, because this is B and defective, A and defective, or C and defective. So this is or. So the probability of this union here, considering that mutually exclusive, is the sum of this probability with the sum of this with the sum of that. So this will be the probability of A and defective plus probability of B and defective plus probability of C and defective. And from our compound probability formula, you can check back in the one of the videos that I already uploaded maybe 2 days ago. You would see that this is the probability of A multiplied the probability of B given A. So probability that the bulb came from A multiplied by the probability that, that's defective. That is defective. And it came from A plus the probability of B times the probability that is defective and it came from B plus probability of C times probability that is defective and came from C. If we arrange this well, then we can just copy the values and put there. That's 30 on 100 times 3 on 100. So probability of A is 30 on 100. Probability of defective, given that it came from A, this is the path from A and is defective. That's 3 on 100. Plus probability of B is 45 on 100 times probability of defective, given that it came from B, that is 6 on 100. Plus probability of C is 25 on 100 times probability of defective, given that it came from that, that's 4 on 100. If we arranged it properly, then this is going to be 90 on 10,000 plus 6 times that is 30, 0, carry 3, 6 times that is 24, and 3, 27 on 10,000 plus 4 times that is 100 on 10,000. And if we sum that properly, this should give us 370, 460 on 10,000. So that's the probability that the bulb selected at random is defective. It's going to be 460 divided by 10,000. You can simplify that if you want, but it's okay. Now C says, given the bulb is defective, find the probability that it's produced by C. So that we're actually looking for the probability of C, given that it is defective. That's what we're looking for. So given that the bulb is defective, find the probability that it came from C. So the probability of C, given that it's defective, this is what we need here. That's what the question says. But I already showed, if you check back the video, please, I advise you to go and look. Then there is simply the probability of C intersection D divided by the probability of D. So this B, the C intersection D, we already saw that this here. Probability that it is from C and is defective, and that's 100 here. 100 on 10,000 divided by P of D that we just calculated. That's 460 on 10,000. If we invert and multiply, then we get 100 on 460. You can simplify that as well. I won't do that. So you can take some time and go through the process yourself. So that was it. Hope you liked it and that you understood the application of tree diagram. Maybe in the future we can look again into some other examples, but for now, good luck. Please remember to give a thumbs up, subscribe, ask your friends to do the same, share with them. Bye.